Let's look at 5 features of the upcoming 1.24 release of Go. Generic type aliases will be introduced in Go 1.24. There are 2 ways to create a custom type in Go: type definition and type alias. Let's look at some code that illustrates the difference between the two. We'll start with main package boilerplate, before defining 2 new custom types, one as a definition and the other as an alias. Next, we'll declare a variable of each of our custom types, initialize them, and finally print each variable's type. If we now run this code, we'll see the difference between the two. The type alias is just an int, whereas the type definition is its own type. So far so good, but let's introduce templating to our custom types. We'll start by making our 2 types generic, updating the declaration, and finally updating the initialization. If we try to run this, however, we get an error telling us a generic type cannot be an alias. Before Go 1.24, only type definitions could be generic, but Go 1.24 allows type aliases to also be generic. If we now run our generic code with Go 1.24, it works as expected. Weak pointers will be introduced in Go 1.24. Go's garbage collector will reclaim the memory of any object that becomes unreachable from your code. Let's see how that works. We'll begin with main package boilerplate. We'll create a function that returns the current heap size. We'll define a custom type and create a pointer to an object of that type. Next, we'll print the pointer, trigger the garbage collector, print the pointer again, then compare the heap size. When we run this code, we see that the pointer is present before and after garbage collection. However, if we remove any mention of the pointer after garbage collection, we see that the heap size is 1000 kilobytes smaller than before. This has happened because we removed the use of the strong pointer after garbage collection. This means the pointer was unreachable from any code after the garbage collection run, so it was removed. Let's now look at how weak pointers affect this. We'll return to printing the strong pointer after garbage collection. We'll add a weak pointer, which we'll print alongside our strong pointer. Running this gives us output similar to our original strong pointer output. Both the strong and weak pointers are pointing to our object, and the heap size shows the object is still allocated. Now, if we remove the strong pointer from after the garbage collection, but keep the weak pointer, we see that the object has been deallocated from the heap, despite the weak pointer still being present. This has happened because the weak pointer was not counted towards the reachability of the object, only the strong pointer was. An example use case of weak pointers is for a cache, where we want objects to be able to expire and be removed, despite still having a pointer. We can perform a nil check on the pointer to see if the object is still cached, or if we need to refresh it. Go 1.24 eliminates the need for tools.go, allowing us to track versions of our tools in go.mod. In Go 1.23 or lower, if you wanted to manage your tools, such as linters, in your project using go.mod, you needed to do a little trick. Let me show you. We'll initialize a new Go module using version 1.23. Now we'll add golint to our project. If we look in go.mod, we'll see 2 dependencies added, but they're both indirect. The next time we run go.mod tidy, we lose them. This is because the only reference to those dependencies was in the golint binary, which isn't included in our package via an import statement. Before Go 1.24, we would work around this by faking the import using a tools.go file. We would include this file in our main package and import our tools to the blank assignment. If we then run go.mod tidy, we'll see it downloading our tools. And if we look at go.mod, we'll see lint is no longer an indirect dependency since it's directly imported by golint in our tools.go. With Go 1.24, we no longer need the tools.go since tools can be tracked in go.mod by adding the -tool flag to the go get command. If we then look in our go.mod, we'll see a new tool directive added, allowing us to track our external tools directly in go.mod without the workaround of a tools.go. Go 1.24 introduces new functions to the bytes and strings packages for working with iterators. Both packages introduce the same functions, so I'll go over them using only the strings package. All of these functions have the benefit of being able to iterate over a slice of data without having to allocate memory for the entire slice. Only the element pointed to by the iterator is allocated. Lines returns an iterator over the new line terminated lines in the string. For example, given a multi-line string in Go 1.23 or lower, we would split the string and iterate over the resulting slice, whereas in Go 1.24 we only need to call the lines function. SplitSeek returns an iterator over all substrings of S separated by the given separator. It can be used in place of split. SplitAfterSeek returns an iterator over substrings of a string split after each instance of the separator and is equivalent to the SplitAfter function. FieldSeek is an iterator based equivalent to fields, splitting the string around whitespace characters. And finally, FieldsFuncSeek is an iterator based equivalent to FieldsFunc, splitting a string into fields based on the evaluation of a function. Go 1.24 introduces an omitzero tag to remove zero values when marshalling JSON. Consider this code. It's a simple example of turning a struct into JSON, and if we run it, we can see our JSON object. Notice the time value in the printed JSON. Our message struct had an uninitialized time in it, which got translated to this zero representation of time when marshalled. In order to remove the empty time, we can use the new omitzero tag in our struct like so. And when we run this, we no longer have a time field in the JSON. Zeroness is determined by implementing an isZero function on the type. The existing omitEmpty tag doesn't work with uninitialized times since they are not technically empty. I'd love to know in the comments if you're excited for any of these new features, or if there are new features you want me to take a look at in a later video.